Hello everyone. We're going to resume our class of Eurocode 7, Geotechnical Design. I think we are on the chapter number 8, slope stability, embankment, and hydraulic failure. So with this video, we will try to finish everything about slope stability. And then next time we will start with embankments. Okay, so chapter 8. And I think this was the content of the chapter. So three parts, or maybe four. The part 1 is about slope stability. Part 2, embankment. Part 3 is hydraulic failure and summary, and we will do some examples. Okay, so we did last time this slope stability, and we started slope stability analysis last time. We didn't finish it. We will still continue it, complete it, and finish up with the serviceability limit state design of slope. Okay, so that means slope stability analysis, the first part, and the subsection, these two subsections. This is what we are going to talk about today. Okay. So let's continue with the slope stability analysis. Okay. Last time, the one we discussed here was the infinite slope analysis. So this time we are going with a general stability analysis. Okay, general stability analysis for slope stability. So in Eurocode 7, part 1, this section is saying that slope stability analysis should be verified the overall moment and vertical equilibrium of the sliding mass. Okay, so it also saying that if horizontal equilibrium is not checked, the interslices forces, which means when using the method of slices, don't worry, we will see what is method of slices soon. It should be assumed to be horizontal. And this means that some slope stability analysis method are not accepted. So, okay, all this means that for those who study soil mechanics 2, and if you didn't study that, I recommend you go to my soil mechanics class. There are several methods to analyze slope stability. Okay, Eurocode didn't really bring something very new. It just recommending some methods. So these methods are different, and according to what Eurocode is recommending here, not all method can be used. Okay, so in this we will show you what method can be satisfied Eurocode recommendation for slope stability analysis. Okay, so information about the equilibrium equation that are satisfied in the interslide forces, interslide force characteristic, and relationship in different method of slide are given in the following table. I'll show you the table. These are the table, for example. Okay, so we need to check two part: moment equilibrium and force equilibrium. Okay, we have to check this because these two are what Eurocode is focusing on. So these are the different methods of analyzing slope stability. There are very many methods. Okay. So if you see each of them, ordinary or Fearless method, you can see that this can satisfy this moment equilibrium, but doesn't satisfy the force equilibrium. Okay. Yeah. So if we go back the previous slide here, it is saying we have here slope stability analysis should verify the overall moment and vertical equilibrium. Okay, overall moment and vertical equilibrium of sliding mass. Okay, and it also states that horizontal equilibrium is not checked. If the horizontal equilibrium is not checked, the interslide forces should be assumed to be horizontal. Okay, so we have to focus on this. We have this yes here, no here. This simplified method, this method is used in many codes, actually, in many countries. It's satisfied here, but not here. So you can read by yourself. There are several methods. Okay. Some satisfy both. For example, this one satisfy here and here at the same time. Okay. So this table is showing equation of equilibrium satisfied in method of slices. Now, interslices force characteristic and relationship in method of slices. So we can see here the method. Now, interslice normal, interslice shear force, sharing forces, and inclination of x. You can see x is this one, E is this one. It means sharing and normal, shear force and normal force. So the resulting force and then relationship between X and E. So for each method again, we have if the method satisfies it or not in these cases, and if the relationship inclination is constant horizontal, or the inclination like here, inclination of ground surface at top of slice. Okay, so this table we just saw, the two tables, they show that this Spencer's method is acceptable because both moment and forces equilibrium equation are satisfied. I will go back again in the previous slide. This one, you can see yes here, and it's constant. If you go again up this method, you can see yes here, okay? So not any method can be used in Eurocode. Eurocode is recommending. So this method is acceptable because both are satisfied, both conditions are satisfied. The Bishop's simplified method is acceptable also because moment equilibrium is satisfied, and while the forces equilibrium is not satisfied, the interslice forces are horizontal. So let's go back again in the previous slide and show you what does this mean. Okay, remember that in the Bishop method we have this moment equilibrium is accepted, is satisfied, but the force equilibrium is not satisfied. But why it is still acceptable? Because the interslices forces are horizontal. Okay, the inclination. So I'm going back in the previous slide. here, this one, first table, you can see the Bishop's method, Bishop's simplified method. I don't know, maybe Bishop's or Bishop. I am reading in French, sorry. This one, it's saying yes here for the moment equilibrium. But the force equilibrium, it is not satisfied. It cannot satisfy them. For this reason, normally, this method should not be considered, should not satisfy Eurocode recommendation. But if we go in the previous slide of Eurocode, it's saying here, sorry, first overall moment and vertical equilibrium of slide should be satisfied. Okay. If horizontal equilibrium is not checked, okay, the interslide forces should be assumed to be horizontal. And because the Bishop's method satisfies this, then the method can be considered also. Okay, so the Bishop method satisfies this moment equilibrium, yes, but for the force equilibrium, no. However, if we check here, Bishop's simplified method, the forces are horizontal. Okay, horizontal. Because of this, this Bishop's simplified method can be used. Tell me, is it Bishop or Bishops? I'm not sure. So that's why we say here, this method, Bishop simplified method, is acceptable because moment equilibrium is satisfied. But even if the force equilibrium is not satisfied, the interslide forces are horizontal. Yeah. So Jan Boo's method is not acceptable because the moment equilibrium is not satisfied. Okay. We go back again, the previous slide. This one, you can see it not satisfying the moment equilibrium. So cannot accept that, okay? Pelon's method is not also acceptable because even if we have the moment equilibrium satisfied, forces equilibrium is not satisfied and the interslide forces are not horizontal, okay? It almost similar to the Bishop method, but the problem is in this case, the interslide forces are not horizontal, so it cannot be accepted. So if you go in the previous slide, here again, sorry, you can see, where is it? Okay, we don't have it here. Yeah, we don't have it here. So we just refer on what the test said, what this paragraph said, okay? So anyway, you understand now, we have two acceptable method, this method and this method. This method is very famous. The Bishop method is very famous. Please, if you don't understand this method, go in my soil mechanics class. You will see what we are talking about here. Okay. So before we continue, I'm going to talk a little bit about this method, Bishop simplified method of slices. So I think you remember what is this? The failure envelope more column.